All right, so getting into chapter 6, we're going to start taking a look at the object-oriented programming aspects of the Java language. So we're going to start off with this by taking this first look at classes, where we're going to go through essentially just an introduction to understanding what classes are in a bit more detail. What do these classes consist of? So what sorts of things do we need to include inside of them? How do we go about actually designing those classes so that then we can go ahead and implement them, actually write out programs for them, and then use them in those programs. So to initially get started with this first look at classes, I'm going to go through a sort of general abstract explanation of precisely what classes are and how we will eventually go about writing them in our programs. So to get started, we're going to be looking at both objects and classes. So classes are going to be the blueprints that we use to construct objects. We want to make sure that we keep in mind this distinction between an abstract definition, such as the blueprints to a house, and then the concrete objects, such as the houses themselves. So when we talk about objects and classes, we want to make sure that we understand that those are two very distinct things. Essentially, the relationship between them is that we're using the classes, so the blueprints, to actually make or construct the objects that we're going to use later in our code. So a class is going to be the code that describes the object, including how to actually go about constructing that object. So just like a set of blueprints describes how to construct a house, the class, the code that we've written, describes how we go about constructing our objects of that class. So there's going to be some file of Java code that will contain a combination of data in the form of fields and then behaviors in the form of methods for that class. So to address that question of what it is that we're going to be putting inside of our classes, it's going to be these fields and methods. So we'll have some set of data, so attributes to describe the, in most cases, the attributes to describe the objects of that class, and then some behaviors or methods, essentially things that those objects can do. So each object, we could also describe that as an instance of the class. So it's sort of like a realization of the abstract blueprints. That's what those concrete objects will be. This is going to be similar to how actual houses are instances of the description in their blueprints. Another way to describe constructing an object is to say you are instantiating an object of the class. So taking that word instance, just kind of stretching that out a little bit to say that we're going to instantiate it, or that this is an instantiation. So to give you an example of this, we've already seen before a couple of different instances where we would construct our own objects. So we've done that with, for example, the string class. In order to construct objects of the string class, there needs to be a class that describes how to construct those objects. So that tells us that there's some Java file somewhere else, not in our program, but somewhere in that library of different Java files. Somewhere inside of that, you would find a Java file specifically for the string class, and inside of that string class you're going to find some description in the form of a method of some kind, since this is something we need to do, that explains how to construct the objects of that string class. So in addition to that, this class is going to specify the data, which will be some sequence of characters, and we know that our string objects consist of a sequence of characters, and then also the behaviors. So in addition to some behavior, so some method for constructing objects, we also find methods, say like the ones that we've used before, like to uppercase or equals. So all of the classes that we've used so far come from the Java Application Programming Interface, or Java API. The Java API is another way to describe the Java library. So we can see right here, the Java API is a library of classes contained in different packages for you to use in your own programs. So if you were to take a look somewhere on your computer system to go try to find that that Java library, you would see that it's essentially just going to be a bunch of different folders that represent the different packages, and then inside of each of those folders you would essentially find a bunch of Java files for all the different classes that you've been using. And then if you took a look inside of those classes, you'd be finding those fields and methods for each class. So another way that we can describe the relationship between classes and objects is to consider a factory that mass produces some kind of product. So we can think of the class as being like that factory, and then the products being manufactured are the objects that you're constructing. So in this case, we're describing it here, where we essentially have some kind of factory that just makes strings, so it just makes these sequences of characters, and then outputting from that, or some product that we're getting out of that factory, could be the string here for hello world. So in addition to our analogy of blueprints and houses, we can also think of it like a factory and some products that we produce from that factory. So another thing that I want to talk a little bit about is going to be what is known as encapsulation. So this is going to be an important concept related to the way in which we go about writing our classes. This is going to describe the act of enclosing or containing something. So in programming, encapsulation focuses on containing internal details in such a way that the user does not have to know how every aspect of your program works in order to use it. So what I mean by that is that essentially when your user is using some kind of program, the only thing that they're really concerned with is what they need to do as far as the inputs that they have to put into the system, and then the outputs that they're expecting from it. As far as how all of that works, how those inputs turn into those outputs, they don't really care about what goes on behind the scenes. The only thing that they're concerned with is that it works, and that it works properly. So a couple of different examples. The first one we'll look at here is going to be what is known as data hiding. So this is to say that the fields of a class are kept hidden from other classes, and only through methods can these fields be accessed. And eventually, when we go about implementing our own custom class, we're going to be making use out of a few keywords to do this. So the public keyword is going to indicate fields and methods that can be accessed by other classes. Conversely, the private keyword is used to indicate fields and methods that cannot be accessed by other classes. So the ideal approach here is that you always make sure that your fields are private. These are kept hidden from other classes. And then the methods that will access or use those fields in some way, those methods are going to be public. So those can be used by other classes. So encapsulation is also going to include implementation hiding. This is to say that you do not have to know precisely how a method works in order to use it. So a pretty good example of this would be the square root method that comes from the math class. You don't really have to know the math used to calculate the square root of a number. So don't really have to worry too much about the sort of complex process about determining how one number, when you use that and you divide it with another number, just gives itself. Instead, the only thing that you really have to care about is that it gives you the correct result. So it just needs to work the way that it's intended to. So when we combine both of these forms of encapsulation, we have our data hiding and our implementation hiding. We can essentially describe our objects as like a black box. So you only need to know enough to be able to make the objects do what you need. You don't have to worry too much about the internal details about it. So another aspect of objects that we need to be aware of is going to be the distinction in variables from primitive data types. So when we think of an object, essentially that object needs to be associated with some kind of variable, a variable whose data type is the same as the class of the object. So if you think about it, say a string variable needs to have a string literal assigned to it. That string literal would essentially be a string object. So there needs to be a relationship like that. But of course, the variable for a string, that's going to be different from, say, the variable for an int or a double, in the sense that with primitive data types, the variable is the location in memory where the data itself is held. So at the same place where you would find the variable, that's also the same place where you would find the value itself. So in this example we have right here, the value 10 is located at the memory address called number. So whatever address that happens to be, both the variable number and the value 10 are both located at that same spot. But with objects, it's a little bit different. So with objects, the data held at the variable's location is actually going to be a reference to the object located somewhere else in memory. So this is why it is that we refer to these variables for our classes, say like this scanner variable that we've created right here. we call those reference variables because the thing that they hold is actually a reference rather than the object or the value itself. So in this case, we declare a reference variable, and we're going to assign a reference to an object. And of course, in a lot of cases, whenever I describe this, I kind of shortcut it and just say that the variable itself is the object, since the relationship between them is so compact. But if you're trying to be very specific and very technical about this, it would be appropriate to say that the reference variable and the object itself are two different things. So in this particular case, we've created a reference variable. We call it keyboard. And then we've got our actual scanner object that's located somewhere else in memory. And then that reference just kind of directs us or points us to where the object is located. So we show that relationship here where the reference variable and the object are completely separate things. So they're in completely separate locations in memory. So if we were to describe this another way, we could imagine that the reference variable is, if we're describing it as a box, so we're going to refer back to that box analogy that we used back when we were talking about variable declarations. We could describe a reference variable as being a box that contains a key, and this key is going to be used to open another separate box, and that other separate box is going to be the object itself. And the primary reason that I would describe this as a kind of key and maybe some locked box, that particular analogy, is because of the fact that when we go to open the object up, we keep in mind that this is kind of referring to encapsulation in the sense that the data is kept hidden inside or kind of locked inside of that box. So this kind of helps to provide a more visual description of the distinction between our reference variable and then the object itself that's somewhere else in memory. So at this point, this is going to wrap up the initial introduction. Listing right here, we're going to get into this next part where we're going to talk a little bit about how to actually go about writing or implementing these classes, where we're going to go through these different set of steps. So we'll go ahead and do that in the next video.